Hello and welcome to today's webinar. So today we will be looking at some best practices in case of mission planning with 3Dsurvey pilot. So the topics that we will be covering today are best practices for recording 2D orthophotos, volume calculations, 3D models, road mapping, and there will be two additional topics that are for now only available for iOS version of our software. So that will be the KML import and how we can resume an interrupted mission in case we, for example, change the battery and we want to continue from where we left off. So let's go right ahead. So the first option we will be looking at is 2D orthophotos. So in cases when the end result will be a 2D orthophotos, we recommend you to use a simple grid flight plan option. So this is the most simple option, and it's best because it won't produce too many photos. Because for orthophoto only the top-down images are required. So therefore we like not to complicate too much things, and we just recommend to use the single grid option. So as usual, we recommend you to use between 65 to 80% overlap and side lap. So the value that we recommend at this point will be 70%. We recommend you to keep the camera down at 90 degrees. For flying height, we recommend you to use 80 meters. That should give you 2 cm resolution with phantom drones. And to trigger cameras in flight. So the thing that makes the data accurate should be the ground control points. Most of you already know this. We recommend you to place the ground control points with 100 meters spacing. The difference is only for the RTK drones. There so many ground control points are required, so in that case 4 GCPs should be plenty. Now let's have a look at how we plan a mission in practice. Okay, so here we are on our iPad, so we will be first selecting a grid mission. Now we will place it on our area of interest and we will just stretch it to cover the area that we want to map. So in this case, using a rectangular mission is very beneficial because as a result we will also get a rectangular orthophoto map. So that's why a simple grid mission is also very useful. So now we have defined our area of interest. Now what's left for us to do is also to maybe change the flight parameters. So here in this case, the only thing that we need to do is change the flying height, which we will now change to 80 meters. So now we have here an area of 300 by 300 meters. So if we fly with a regular phantom drone, the best positions to place the ground control points would be here in the areas where we have these points. So we would place 8 ground control points here where we have dots around the area of interest, and 1 we would place in the center of our rectangle. So that would allow us to get the accurate results, and then that's it what we need to do in order to plan the mission. So now we will also have a quick look at how a successful mission then looks in 3Dsurvey. Okay, so here we are now in 3Dsurvey. So we flew our regular grid missions. These were the aerial images. Now let's check out the results that we obtained. So here is now the point cloud for our area of interest. So in this case, even from top-down images only, we were also able to calculate quite a bit of facade. So we also have quite a lot of facade information, but this might be more down to the fact that the buildings in our area of interest have very little roof over the facade. So because there is not much roof over the facade, we also were able to calculate the facade information, which was okay for this. So from this point cloud, we then created the digital terrain model for our area of interest. And lastly, the result that we were looking for, our orthophoto map for this area. So you will notice that we had pretty small area of interest, so we signalized only 6 ground control points in this area. So this was now the first example. Now let's continue to the next one. The next step is volume calculations, or we also call these 3D focused missions. So in cases when we want to get a really nice 3D terrain, or we want to make a nice map that is 3D focused, in this case we can also fly double missions. So for this example we will say fly polygon missions, but of course you could also use the grid mission if you liked. So the overlap and side lap settings should be same. So if our area of interest will be bigger, you can decrease the side lap and keep the overlap at a high level, and if you decrease the side lap, so that will mean that with the same battery you will be able to cover bigger mission. Camera angle. So here in the case when we have single missions, we recommend to set camera angles to 90 degrees, so that means looking down. But in the cases when we use double grid, then we can use camera angle between 80 or maybe 85 degrees. So flying height, again we recommend to use 80 meters because that will give us 2 centimeter resolution, which is enough for most applications. And we recommend you to trigger the camera in flight. So we have also here option to trigger images in flight or to direct the drone to stop at each image position, but that will take considerably more time. So that's why in-flight options should always be used. And one of the good practices is in case when we will be measuring volumes over extended period of time, we recommend you to always signalize a point on the ground and measure it with the GPS every time you do measurement. In that way, we can also check the accuracy of our GPS data. Now, let's have a look at how we do mission planning for volume calculations. Okay, so we are back on our iPad. For this example, we are using polygon mission. So now we will move to our area of interest first. So this one is a little bit out of our location. So we will zoom in here and tap to add the location of our polygon. Now we can just move the polygon points so that we will cover our area of interest. So tapping on one of the plus signs adds a new point. Now we will change the flight path so that it will go up and down our area of interest. and again we will change the flying altitude to 80 meters high. Because the flying path for this one would only take about 4 minutes, we can now use the double grid option instead of single grid type. So that means that the whole flight will take now 9 minutes instead. And because we are using the double grid, we will change the camera angle to 85 degrees. So this is now our mission. Now let's also have a look at what results did we obtain by flying this kind of a mission. So now let's also move to 3Dsurvey. So here we are now back in 3Dsurvey. So here we already see the point cloud from our area of interest. So here was also the point that was signalized with a survey marking. So here is one point that we measure every time when we come to this terrain. And these are now the results of our surveying. So we have first measurement, second measurement. So here is our digital terrain model and our orthophoto for this area of interest. So what was even more important here were volume calculation. So this is what the situation looked with the excavation completed. We have here the situation before the excavations, and we have here the final situation. So based on these situations, we were doing the volume calculations. So here we see different volumes that we were measuring. So for excavations, for road, and for the piles of the material. We made some vertical cross sections that are displayed here. And here we have some volume calculations that were done for different parts of the terrain. So first we have the volume that was done for this road that was here, and for the backyard. So the big one for the new object, and then the volume of the material added to the site after the excavation was done, and material added to the site here. So it's a pretty complicated situation, but with these volumes we were able to show the excavations and the amount of material then added back to the site after the excavation was completed. Okay, now the next mission type. So when we want to create a 3D model of an object, maybe a house or a building, we can also use circular or ellipsoidal flying path. So in this case, we will direct the drone to orbit our object of interest. By default, you should set the angle between images to 10 degrees in horizontal direction. So in this case, the camera angle will be calculated automatically. We will check that right in a couple of minutes. and altitude can be selected based on the diameter and angle we want. So in this example, it's important to note that the camera can also be manually adjusted if the view that we get is not the one that we want. And now let's have a look at how we plan a orbit mission. So we are back on our iPad, and in this example we're now setting a circle mission. So we will set the circle around this long building. Now we will increase our flying path. So now it's about 200 by 200 and 250 by 250. Let's decrease it a little bit. We can use the rotation tool here on the right in order to position it around. So we can also set the flying path to ellipse. So I'm just now finishing the fine-tuning the flying path. So now here we want to set the flying altitude so that we will get a nice camera angle. So with this setting we get the camera angle 25 meters. If we adjust the flying height, then the camera angle gets recalculated. So in this case the camera angle is calculated automatically, so that the camera is always pointing towards the center of the ellipse. So if we decrease the diameter of our ellipse, then also the camera angle changes. So if we want to get 60-degree angle, so to have camera looking down at 60-degree angle, at this size we should fly at 115 meters altitude. Okay, just a little bit of problems with our display, with our flying path. Let's just get it back. Okay. So here it's now important to note that camera angle was calculated automatically, so that the drone will always be looking at the center of the ellipse, but during the flight, user always keeps the manual control of the camera. So if we change the angle of the camera based on our needs during the flight, we can change what images will be recorded. So that's always a good option for this kind of flights. Now let's have a look at a 3D model of a building that we created with this approach. Now we have moved back to 3Dsurvey, and here I already have a project that we did. So for this example, we didn't do just one orbital flight, we also did one grid flight, and we did 3 circles. One over this small object here, and 2 circles around this old mill. So this was our flying path, and then, because we wanted to get more detail, we also added some additional shots. So we also flew the drone manually close to the objects, and we also recorded these images. Now let's have a look at the result that we calculated. This was the resulting point cloud. So using those additional cameras from here, it really helped to get a lot more detail in this area. So if we now zoom in to the detail here, we can see that we can actually read the house number from the house number plate, and the detail that we got was pretty amazing. So without those additional headshots, the quality of the 3D model is still pretty good. So you will notice we are missing a small bit here below the roof. That's because we only took images from this perspective. But all in all, this is very high accuracy of the data. We see very little noise. And this kind of point clouds can now almost compare to the results of laser scanning. So we get really high fidelity 3D point cloud just by doing a couple of circles over our area of interest. So what do you think? Pretty nice, huh? So what was visible in the photos is now basically visible in the 3D point cloud. Maybe if we go back to photos, 256. So from this photo, this view was calculated. Very close together, isn't it? Okay. So these are our advices for doing the mapping of objects. Now let's move to the fourth example, that will be road planning. For linear objects, we want to fly parallel lines parallel to the linear object that we are measuring. So again, here we are using an overlap between 65 and 80%. In these examples, we sometimes use higher side lap. So for example, 80% side lap, because our area of interest is usually more narrow. We will see that later. Again, we use camera angle of 90 degrees and flying altitude of 80 meters. Now let's have a look at how we plan a mission in 3Dsurvey Pilot. Okay, here we are back in 3Dsurvey Pilot. Now for this mission, we will move again further away from our location to the area where we recorded the mission. So this one was pretty far off, and actually we measured this mission 1 week ago, so this data is pretty new. Okay, here we are. So here we will now just click to define the axis of the road that we want to map. So 3 kilometers, that was the length of the line that we did. So now here in the flight parameters, we set how many lines do we want to fly. We set the flying altitude again. So in this case we will increase side overlap because we don't need to get such wide area, and the drone will fly up and down parallel to the axis that we selected. So we have different options. We can fly 3 or 4 lines. If we fly 3 lines, then the start and the end point will be at opposite ends. If we fly 4, 6 or such even number of lines, then start and end point will be on the same location. So depending on what you like. So in this example, what we did was, when we flew, the operator walked this distance and then landed on the other side of the area of interest. So keep that in mind when you are selecting the number of lines. Now let's have a look at this project in 3Dsurvey. And we are back in 3Dsurvey. So this is what our area of interest looked like in 3D. So it actually was composed out of 3 separate flights. So this is a 3 kilometers section of a 20 kilometer route. So this survey was needed because a new cycling road will be constructed along the main road. Now let's just move to the point cloud. It's a very big point cloud of 250 million points, so it took a few seconds for it to load. And this is what we were able to map in under an hour of mapping. So these are 3 kilometers. So 3 kilometers, that would take you a good half an hour just to walk along this path. And for this example, the drone that was used was actually DJI Phantom RTK. You can tell that it was RTK by the fact that the Phantom RTK writes image name in this form, so they dropped the word DJI. And here for this example, we signalized quite a few ground control points. But then for processing, we only used 2 ground control points on each of the sides. So 2 at the bottom, at the southern, and 2 at the northern part of our area of interest. And the rest of the ground control points, so those were the green ones. The green ones were used as ground control points. And those orange ones, the orange ones are only used as validation points. So then we can check what kind of accuracy would be obtained if only 2 ground control points were used here. I mean only 4 ground control points. So then these points, they are only used to check the accuracy of the data, and we see that we are around a centimeter accuracy in each direction. So then that comes that to 2 centimeters for this point. We are below 4 centimeter accuracy. Of course, the data would be even a bit higher if all points would be used as GCPs. So the middle points wouldn't be used as validation, but for this demonstration I just wanted to show you what kind of accuracy can be achieved with very little work, because setting 2 ground control points on each side of the survey area, it doesn't take a lot of time. Then the drone flight, for these 3 kilometers, it will take maybe 3 batteries. So that will then take maybe around 1 hour, and in less than half of day's work we can then get this kind of a result with a centimeter grade accuracy. So Now the civil engineers and architects will be able to use this data to plan new road for the cyclists, which will go somewhere along here, and based on that it's a pretty nice project that we can do now very effectively. So here we also have our digital terrain model, and of course also the orthophoto for our area of interest. So the only problem remains the areas under the trees, so whatever we cannot see, that we cannot map. So here you see you still have a couple of this kind of areas. So unfortunately there's not much that can be done about that. But all in all, I would say an easy job. So less than a half day of work and you can get this kind of a result. So I think that's pretty amazing. Okay, so we have now looked at three basic mission types. So regular grid mission type for when our main result will be orthophoto of a rectangular area. Then we looked at how we plan missions when we are doing volume calculations. We looked at circular missions for doing 3D modeling of objects, and now lastly road mission for mapping linear objects. Now let's move back to our demonstration. Now the newest iOS version of 3Dsurvey Pilot has some additional functionality, which is called KML import. So we had quite a few customers asking us about the ability to define missions in Office on desktop PCs, and then when you get out on the field you want to be able just to fly the mission, not select the flying path there. So we came up with a simple solution that allows you to draw missions on desktop PC. So we use Google Earth to define the flying path there, and then we can send it to our mobile device, to iPad, iPhone, and eventually in a month or two it also Android phone, and then we can there use that KML to define the mission area. So let's now have a look at how this is done. So we start by starting Google Earth. Now, as usual, first we need to zoom in to our area of interest. So for our demonstration purpose, we will select this grass field here in the center. Then we just click create new polygon. We will name it polygon example. Okay, now we just start defining the polygon. Okay, just a couple more clicks. Just for display purposes, we will change the opacity down to some 70% so that we can see what area we have selected. So this will be our first example for polygon area. Now let's create a second example. We will name this one path example. And this one we will use to show how we use for path and for polygon. Now we will also define a path that we would like to map. Like that. And let's add a few points here. Okay. Okay. Now we will save the polygon example as KML. So just change the file type to KML. Save. Same thing for the path example. Save it as path example KML. Save. Okay. Now I have sent myself those two KML examples on the iPad. We just long press on that polygon example and select open it with 3Dsurvey Pilot, and immediately it comes into 3Dsurvey, and here we can then set our flying parameters, so just like we would do otherwise. So we can change path angle, flying altitude, overlap, if we want single or double grid. Now let's check the same workflow for the path example. So let's go back to our email. Now long press on the path example KML, select copy to 3Dsurvey Pilot, and again it gets automatically thrown into road mission. So we have here our road mission defined, and again we can change the flying parameters, maybe change the number of lines to, for example, 5, or back to 4, and also maybe change the flying altitude. So now again, this is the functionality that is for now only available for iOS, but also the Android version of this functionality is on its way, and it should reach you in about 1 or 2 months. Okay. Now let's just check one more functionality that is only available for iOS for now. So resuming interrupted mission. So this was the second functionality that we got a lot of requests for. So it might happen that you plan a very big mission, so the drone will drain its battery. So you need to land in the middle of your mission, you change your battery, and then you would like to continue from the last position that the drone was able to record the image for. So this latest version also has now this functionality. Now let's have a look at how this looks in practice. So we're running this demonstration in simulation mode. Now the iPad and the drone are connected to the PC where we are running the simulation. So that's why you're also able to see the drone position here. So we have defined a very simple mission, and we will show you now what happens when we interrupt the mission. So now we have clicked to start the mission, so the mission is being uploaded to the drone, and we press play, and the drone now begins to move to the first point of our selected area. So now it is beginning to record the aerial photos. We will record just a few, then we will press, now we have pressed cancel mission, so the drone is now returning to the start point. We now quickly press the start mission button again. The mission gets re-uploaded. We press start again, and even though the drone was interrupted, it is able to continue from where it was at last. Let's cancel the mission once again. the drone starts heading back to the starting point. We can now also land it and change its battery. When we press start button again, the mission will get re-uploaded to the drone, and it will begin again from the position it was at last. So now it's moving again to the next position, so that will be here, and it will then continue to record the aerial images. So this functionality will help for larger areas where you won't need to calculate how much battery to get out of the drone. When the battery gets low, we just land the drone, change the battery, and then continue along our flying mission. So this is what we had prepared for you today for our webinar session. You're welcome to join us again next week when my colleague Marco will take over. Until then, have a nice rest of the day and happy 3D surveying. Bye bye.